Hi, in this video we are going to test our application. So I'm going to create the main method. I'm going to have a list, and first we would like to store integers, for example. This is my list. It's going to be equal to a new linked list, as we have implemented in the previous videos. I would like to insert some data, the 10. I'm going to copy and paste sometimes. For example, -2, +3, and for example 100. I would like to traverse the list. So traverse the list. Let's check whether it's working fine or not. Hit the play, and as you can see, it's going to print out the values. Okay, I'm going to make some other spacing because it is misleading. Sorry for that. So here I'm going to set, for example, an arrow. Okay, so if we run our application again, as you can see that we have managed to insert items at the beginning. So 10 is the first item, then -2 will be the first item. It's going to point to 10 after inserting -2. After inserting 3, it's going to be the root node and it's going to point to -2, and -2 is pointing to 10. Then we are going to insert 100 and it's going to point to 3. 3 is going to point to -2 and -2 is going to point to 10. So what if we remove, for example, the 10? Okay, we have managed to get rid of the last item. What if I would like to get rid of the first item? Okay, we have managed to get rid of the first item. What if I would like to remove some internal node? We have managed to get rid of some internal node. And of course, for example, I'm going to print out the size of the list. So the list.size is going to return the size of the list. In this case, it's going to be 4. Okay, so basically this is how we implement a linked list. Why is it good? Because it is generic in the sense that I can use it, for example, to strings. I would like to store, for example, names. Adam, Kevin, Joe, Michael. Okay, I would like to print out the size and I would like to traverse Michael, Joe, Kevin, Adam. So this is why it is a very good programming practice to make everything as generic as possible, because we could use it for integers, for doubles, even for custom objects. Let's consider the fact I'm going to create a person. We would like to insert custom objects. Okay, I'm going to have a private integer, string name, and a private integer age. In the person constructor, we are going to have an integer age and a string name. I'm going to initialize the age and the name variables accordingly. This.name is equal to name. I'm just going to override the toString method. I'm just going to return, for example, the name. So return this.name. And of course, I'm going to have some getters and setters. So generate getters and setters for the age and for the name. I'm going to hit Ctrl+Shift+F to auto format. It's very important that we have to implement the comparable. Let's take a look. Okay, I'm not going to implement the comparable interface because we have implemented node to get everything. This node is going to be able to store everything that extends the comparable interface. So whenever I would like to store, for example, person objects in this list we have been implemented, and if you hover your mouse over this, then bound mismatch, the type person is not a valid substitute for the bounded parameter. And basically, the bounded parameter is this t extends comparable. So we have to tell the person that it's going to implement the comparable interface, and of course it's going to store a person. And here we have to define that according to what we would like to compare our custom objects. I would like to return, for example, integer.compare, and for example this.age, and I'm not sure what's the name of the other person, for example person.getAge. Okay, so basically with this we are able to store person objects, and I'm going to insert, for example, a new person with the age 10 and the name Adam, then another person, so new person with the age 22 and the name Joe. I'm going to copy and paste it, going to insert it with the age 1 and the name Kevin. I would like to insert it, for example 45, and I would like to specify, for example, Michael, whatever. So we are able to traverse this linked list. Okay, it's going to store person objects instead of strings and integers. So we can use it because we have implemented it in a generic manner. And basically, why is it important to make this comparable interface? Because this is how we implement it, okay, but in the linked list, this is how we are able to decide that actual node get data compared to is equal to 0 or not. So this is how we are able to detect that two objects, two of these t parameters are equal or not. Okay. So for example, let's see, I'm going to have the list.remove, and I would like to remove the first person. Of course, I have to extract it. So person p is equal to the Adam, and we have to insert the p here. So I would like to get rid of the Adam. Let's see whether it's going to work fine or not. We have managed to get rid of Adam. Okay, so basically this is how we implement linked list in a generic manner that can store integers, strings, custom objects, and whatsoever. We have to create a distinct node. We have to define this list, so what's going to be the behavior of the linked list, and of course we have to implement it. And basically we can use this insert data at the end, but usually we use linked list with inserting data at the beginning. This is why we like linked lists. Thanks for watching.